Good morning, everyone. Welcome to the next lecture. Today we will discuss the eigenvalue and eigenvector of a matrix. We will look at here what actually mean by the eigenvalue and eigenvector and then go for finding the eigenvalue and eigenvector of a given matrix. See here, the eigenvalue are the special set of scalar value that is associated with the set of linear equation in the matrix. So it is mostly used in the matrix equation. So here Eigen is actually a German word that means the proper or characteristics. Therefore, the term eigenvalue can also be termed as characteristics value or characteristic root, or it is also known as proper value or latent root as well. So an eigenvalue of a square matrix, see for example matrix A, is a scalar. For example, I am denoting in terms of lambda, such that when given matrix A operate on the corresponding eigenvector, for example, I am denoting in terms of x. So the resulting scalar multiple of the vector, that is x. So mathematically we can express as the basic equation format, that is Ax is equal to lambda x. Here A is the, it is original given matrix, then x is the eigenvector and lambda is the, it is the eigenvalue. So here the number or the scalar value lambda, which is actually representing the eigenvalue. So now as against the eigenvalue, we have a eigenvector as well. See, it is a non-zero vector that can be changed at most by its scalar factor after application of a linear transformation. So an eigenvector of a square matrix A is a non-zero vector. That means when multiplied by the matrix A, which results in a scaled version of itself. In other words, we can say that, see, the direction of eigenvector remain unchanged under the linear transformation represented by the matrix A. So while its magnitude may change, of course, so the scaling factor by which the eigenvector is sketched or compressed is called eigenvalue associated with that particular eigenvector. So it will be more clear when you go for solving the examples. So here how to find the eigenvalue? See, in order to find the eigenvalue, we use the formula for determining the eigenvalue. We can start with the definition of eigenvector, that is Ax is equal to lambda x. See here, A is the matrix, that is x is the eigenvector and lambda is the eigenvalue. So in order to rearrange this equation in such a way that facilitate the identification of an eigenvalue and eigenvector, we are going to multiply the given formula by using an identity matrix here. So here I am introducing an identity matrix, that is I. So Ax is equal to lambda into identity matrix into x. So if you go for multiplying any particular matrix by using the identity matrix, it cannot going to change or it will be unchanged. So it will become, see, Ax is equal to lambda into identity matrix into x. Now we can subtract the lambda into identity matrix into x from the both side of the above equation. Then it will become, see, it is Ax minus lambda identity matrix into x, which is equal to lambda identity matrix into x minus lambda identity matrix into x. So if you go for simplifying it, this will become cancelled out because we have a plus and minus sign here. So it will become 0. Then what is remaining here? Ax minus lambda I into x. So here, see, x is common, so we can factor out the value x. So taking the x into the outside, so what is remaining here? It is A minus lambda I, equating with 0. So here it is 0. So this particular equation, by rearranging this particular equation, we can write A minus lambda I into x, which is equal to 0. So this particular equation is actually states that the matrix that is A minus lambda I times the vector x, which is equal to a 0 vector, So this equation has an eigenvector solution if and only if the determinant of the A minus lambda I is equal to 0. So we will find the eigenvector by equating this particular, that is determinant of A minus lambda I to the 0. So we can solve this particular equation. So accordingly we will get the eigenvalue and the eigenvector as well. So let us consider one example. Find eigenvalue and eigenvector. See here we have a given matrix A that is equal to 5, 4, 1, 2. This is 2 by 2 matrix and we want to find out the eigenvalue and eigenvector. So here we are starting with a square matrix. So it is 2 by 2 matrix we have. We are going to form the characteristics equation. Here it is A minus lambda I, which is equal to 0. So here the A, this is the original matrix. So I am writing first A minus lambda I. So here the original matrix A is equal to 5, 4, 1, 2 minus lambda into, then we have an identity matrix. So here the identity matrix, we have a 2 by 2 matrix we have. So we are going to introduce a 2 by 2 identity matrix. So it is 1, 0, 0, 1. So this is the identity matrix. Now we are going to multiply lambda into the identity matrix. So it will become, see, the 5, 4, 1, 2 minus 1 into lambda, which is equal to lambda. Then lambda into 0, which is equal to 0. Lambda into 0, again it will become 0. Then lambda into 1, which is equal to lambda. So here we have the matrix A minus lambda into identity matrix. So it will become 5, 4, 1, 2 minus lambda 0, 0, lambda. So now I am again going to subtract this matrix, that is lambda 0, 0, lambda from the original matrix, that is A. Then it will become, see, 5 minus lambda, then 4 minus 0, 1 minus 0, then 2 minus lambda. So if you go for simplifying it, then it will become 5 minus lambda, I am putting as it is, 4 minus 0, which is equal to 4, then 1 minus 0, which is equal to 1, 2 minus lambda, it is, I am putting here as it is. Now we are going to find the value, determinant value of A minus lambda into I by equating to 0. So it will become, see, this particular equation, that is determinant of A minus lambda into I. So it is putting here this particular value because we are already estimated here and equating with 0. So here we are going to find out the determinant value of this given matrix. So here it is, 5 minus lambda into 2 minus lambda minus 4 into 1. That is 1 into 4, or it is 4 into 1, which is equal to 0. So 5 minus lambda into 2 minus lambda, it will become, see, 5 into 2, which is equal to 10, minus 5 into minus lambda, which is equal to minus 5 lambda, then minus lambda into 2, which is equal to minus 2 lambda, plus minus lambda into minus lambda, which will become plus lambda square, minus 1 into 4, which is equal to 4, equating with 0. So if you go for simplifying it, then it will become, see, lambda square, this term is here, then minus 5 lambda minus 2 lambda, which will become minus 7 lambda, then 10 minus 4, which is equal to 6. So we have a quadratic equation here, that is lambda square minus 7 lambda plus 6. If you go for solving this quadratic equation, then you will get the lambda value, and that lambda value is nothing but it is the eigen value. So here we are going to solve this particular quadratic equation, that is lambda square minus 7 lambda plus 6 is equal to 0. By using the quadratic formula, we know quadratic formula is equal to x is equal to minus b plus or minus under root b square minus 4ac divided by 2a. So here a is equal to 1, b is equal to minus 7 and c is equal to 6. So if you are substituting all this thing here, then here minus into minus 7, which will become plus 7, plus or minus minus 7 square, which is equal to 49, minus 4 into 1 into 6, which is equal to 24, divided by 2 into 1, which is equal to 2. So here we can simplify. See, 7 plus or minus 49 minus 24, which is equal to 25 under root, divided by 2. So here root 25 which is equal to 5 plus or minus here and divided by 2. So we have a 2 lambda values. One is 7 plus 5 divided by 2 and another one is 7 minus 5 divided by 2. If you go for simplifying it, then lambda is equal to 12 divided by 2 which is equal to 6, or lambda is equal to 2 divided by 2 which is equal to 1. So the lambda, that is nothing but here it is eigen value. So eigen values are here 6 and 1. Now we are going to find out the eigen vector corresponding to the eigen value of 6 and 1. So here we are going to write the characteristic equation by adding the variable matrix here, that is a minus lambda into I, multiplying here with the variable matrix that is x which is equal to 0. So here we are already found this is, it is 5 minus lambda, 4, 1, 2 minus lambda, because we are already estimated earlier. Then we are multiplying here the variables. Variables are here, it is x and y which is equal to 0. So we are putting 2 zeros here. So after that, see, we are going to assuming that lambda is equal to 6. We are already estimated the value of lambda, that is eigen value are 6 and 1. So here we are taking the lambda is equal to 6 and we are going to substitute this lambda is equal to 6 on this characteristic equation. So it will become, see, 5 minus, instead of lambda we are putting it is 6, then 4, 1, 2 minus lambda which is equal to 2 minus 6. Then we have the variable matrix and the constant matrix. Then if you go for simplifying it, 5 minus 6 which is equal to minus 1, 4, 1, 2 minus 6 which is equal to minus 4, then as it is, remaining elements are as it is. Now we are going to multiply the coefficient matrix and of course we are the variables, then it will become matrix through matrix multiplication, minus 1 into x, then plus 4 into y. So I am writing here minus 1 into x plus 4y, then 1 into x minus 4 into y. So I am putting here minus 1 into x minus 4y. So if you go for separating it, so simplifying here, minus 1 into x which is equal to minus x plus 4y, then here it is 1 into x which is equal to x minus 4y which is equal to 0. So if I am separating here these two equations, so here minus x plus 4y is equal to 0, then x minus 4 is equal to 0. We are equating with the 0. So this is the terms. So now we are going to take, see, both are equal. So now we are going to consider one equation, that is the second equation, that is x is equal to x minus 4y is equal to 0. We can write it is x is equal to 4y. Dividing the both side of the equation by using 4, then we can say that it is 4x by 4 is equal to 4 by 4 will become 1. So it will become 4 by 1. I am writing the coefficient in the denominator side. So here the coefficient of x is 4 and y is equal to 1, and this 4 and 1 is nothing but it is showing the eigen vector of corresponding to the eigen value, that is lambda is equal to 6. So the eigen vectors are here, it is 6 and 4. We can write the eigen vector, that is 1, v1 which is equal to 4 and 1. Similarly, we are going to find the eigen vector for lambda is equal to 1, because lambda have two values. So here by assuming lambda is equal to 1, then here we have the characteristic equation we are already formed earlier. We are going to substitute lambda is equal to 1 here. So it is 5 minus 1, 4, 1, 2 minus 1 into the variable matrix which is equal to constant matrix. So if you go for simplifying it, then 5 minus 1 which is equal to 4, 2 minus 1 which is equal to 1 multiplied with the coefficient matrix, that is x, y which is equal to 0. So here now we can go for multiply the coefficient with the variables. So it will become 4 into x plus 4 into y, then 1 into x plus 1 into y. So it will become, see, 4x plus 4y, x plus y which is equal to 0. So I am separating here this equation, that is equating with the 0. 4x plus 4y is equal to 0, that is equation number 1, and x plus y is equal to 0. See, both are the equals, because it is only if you go for dividing with the 4 here, then it will become x plus y, of course. So I am going to consider here equation number 2 and writing it is x is equal to minus y. So here the coefficient of x is equal to 1, I am putting in the denominator side, it is 1. which is equal to the coefficient of y, which is equal to minus 1. So I am putting here in the denominator it is minus 1. So this 1 and minus 1 is nothing but it is showing the eigenvector corresponding to the eigenvalue lambda is equal to 1. So the eigenvector are here, it is 1 and minus 1. We can write it is V2 is equal to 1 and minus 1. So in this way you can find the eigenvalue and the eigenvector of the 2 by 2 matrix. Now how we will find the eigenvalue and eigenvector of a 3 by 3 matrix? See here we have a 3 by 3 matrix, that is matrix A is equal to 2 1 3, 1 2 3, 3 3 20. We have a 3 by 3 matrix. So in order to find the eigenvalue of matrix A, we need to solve the characteristic equation which obtain, that is A minus lambda I, which is equal to 0, determinant value. So here it will become, see, original matrix A I am written here, then minus lambda into, we have a 3 by 3 identity matrix also I am introducing here. Then if you multiply here the identity matrix into lambda, then it will become, see, it is lambda 0 0 0 lambda 0 0 0 lambda. And I am subtracting this matrix with the original matrix, that A, then it will become 2 minus lambda, then 1 minus 0, 3 minus 0, 1 minus 0, 2 minus lambda, 3 minus 0, then 3 minus 0, then 3 minus 0, then again 20 minus lambda. So I am reframed this particular matrix, that is 2 minus lambda, 1 3 1, 2 minus lambda, 3 3 3, 20 minus lambda. Now we are going to equate this particular thing, that is determinant value or determinant matrix, into equate with 0. So it will become, see, 2 minus lambda, this 3 by 3 matrix I am equating with 0, then finding the determinant value here. So the determinant value will be 2 minus lambda into, crossing the concerned row and column, 1 into 2 minus lambda into 20 minus lambda, minus 3 into 3, which is equal to minus 9. Then the second element, that is minus 1, crossing the concerned row and column, it is 1 into 20 minus lambda, then 3 into 3, which is equal to minus 9, plus 3 into, that is third element, crossing the first row and the third column, 1 into 3, that is 3 minus 3 into 2 minus lambda, which is equal to 0. So here if you go for multiplying these terms here, then taking 2 minus lambda as it is, we are going to multiply these two terms. So 2 into 20, which is equal to 40, minus 2 into minus lambda, which is equal to minus 2 lambda, minus lambda into 20, which is minus 20 lambda, plus minus lambda into minus lambda, which is equal to plus lambda square. Then we have here it is minus 9. Then minus 1 into 20 minus lambda, which we can write it is 20 minus lambda minus 9. Then plus 3 into 3 minus 3 into 2, which is equal to 6. 3 into minus lambda, here also minus, here also minus, it will become plus 3 lambda, which is equal to 0. Now we are going to multiply again, see here 2 minus lambda, and this is, we can simplify, 40 minus 2 lambda minus 20 lambda, which will become 22 lambda plus lambda square minus 9. Then multiplying minus 1 into this particular bracket term, so it will become minus 20 plus lambda plus 9 plus, see, 3 into 3, which is equal to 9, minus 3 into minus 6, which is equal to minus 18, plus 3 into 3 lambda, which is equal to plus 9 lambda, which is equal to 0. Now we are going to multiply 2 minus lambda and this bracket term, then it will become 2 into 40, which is equal to 80, 2 into minus 22, which is 44 lambda, 2 into lambda square, which is equal to plus 2 lambda square, then lambda, that is lambda into 40, that is 40 minus 40 lambda, then minus lambda minus 22 lambda, which is equal to plus 22 lambda square, then minus lambda into plus lambda square, which will become minus lambda cube. Then we have here, see, we have 20, here 9 lambda and plus 9 lambda, so it will become 9 lambda minus 20 plus lambda plus 9 minus 18 plus 9 lambda. So if you go for simplifying it, then it will become, see, minus lambda cube plus 24 lambda square minus 65 lambda plus 42 is equal to 0. If you go for multiplying with the minus sign, then it will become plus, see, it is lambda cube minus 24 lambda square plus 65 lambda minus 42 is equal to 0. So now we are going to root of, or we can say that the solution for this particular cubic function, cubic equation. So it is lambda cube. So it is a cubic equation here. So we are solving for lambda here. See, for solving this particular cubic function or cubic equation, see, we are assuming that one of the root of cubic is most probably it is 1, minus 1, or it may be 2 or minus 2. Let us assuming that if lambda is equal to 1, then if you go for substituting lambda is equal to 1 here, then it will become, see, assuming lambda is equal to 1, then we are putting lambda is equal to 1 here, then it will become 1 cube minus 24 into, then it is 1 square plus 65 into 1 minus 42 is equal to 0. If you go for simplifying it, 1 minus 24 plus 65 minus 24, see, it is equal to 66 minus 66, which is equal to 0. So we can say that one of the root of this cubic equation is equal to 1. If it is not coming to 0, then we have to check whether it is minus 1 or not. If it is also not coming, then you go for checking, substituting the lambda is equal to 2. Or it is again, it is not coming, it is minus 2, you go for and check. So accordingly here, the lambda is equal to 1, which came with the 0 value. So we can say that one of the root of this cubic equation is equal to 1. So now I am going to frame a particular table here. See, this lambda is equal to 1, that is one root. I am writing here it is 1. I am writing here it is 1. Then the coefficient of this cubic equation I am going to write here. See here, simply it is the coefficient of lambda cube which is equal to 1. Then it is lambda square which is equal to minus 24. Then we have 65 here and minus 42 I just wrote here. Then see here, I am just going to write this particular coefficient here, it is as it is. Then this particular root I am going to multiply with this 1. So it will become 1 into 1, which I am writing here. It is under minus 24 I am writing here. It is 1 into 1 which is equal to 1. So I am going to add these two terms, that is minus 24 plus 1 which is equal to minus 23 here. I am writing it is minus 23 here. Then I am again multiplying here 1 into minus 23. If you go for multiplying 1 into minus 23, which will become minus 23. So I am adding these two terms here, it will become, it is 42. I am writing here it is 42. So here I am again multiplying 1 into 42. So it will become 42 here. I am going to write it is 42 here. So minus 42 plus 42 which will become 0. So what actually it is showing? One of the root is equal to, cubic equation is equal to 1. Then this remaining values given here, that is 1, minus 23 and 42. These are the coefficient for the quadratic equation. See here, we are going to frame the quadratic equation by taking this coefficient. See here, 1 is used for here lambda square minus 23 lambda plus 42 which is equal to 0. So we have a quadratic equation here. We can go for solving this quadratic equation so that we will get two values or two roots for the lambda. See, if you go for using the factorization method for solving this particular equation, then the product of two factors, that will be 42, and if you go for adding it, it will be minus 23. See, we can say that these two factors are minus 2 and minus 21. So here, if it is minus 2 and minus 21, the two factors are lambda minus 2 and lambda minus 21, which is equal to 0. So by using the factorization method, we can solve it. And at the same time, root which we are already found, that is lambda is equal to 1. So it will become, see, lambda minus 1, lambda minus 2, lambda minus 21, which is equal to 0. Therefore, the lambda r by equating to 0, the lambda r, which is eigenvalues, lambda is equal to lambda minus 1 equating to 0, it will become 1, lambda is equal to 2, and lambda is equal to 21. So we have here three eigenvalues are there. Lambda is representing the eigenvalue. So eigenvalues are here 1, 2 and 21. Now, after finding the eigenvalues, now our task is to find the eigenvector for corresponding to lambda 1, 2 and 23. So here we are going to substitute the lambda in the characteristic equation. So here equating with the 0, in the earlier case similar we are assuming here. So it is the 1 A minus lambda into the identity matrix into X, which is equal to 0. So we are already estimated this value here, that is 2 minus lambda 1 3 1 2 minus lambda 3 3 3 and 20 minus lambda. Then we have a variable matrix X Y Z, which is equal to 0. So here by assuming, see, lambda is equal to 1, that is taking the first eigenvalue, that is lambda is equal to 1, we are substituting lambda is equal to 1 on this characteristic equation, that is here it is lambda is equal to 1. So 2 minus 1, here also 2 minus 1 and 20 minus 1 here. If you go for simplifying it, then it will become 2 minus 1, which is equal to 1, 1 3 1 2 minus 1, which is equal to 1 3, then 3 3 here, then 20 minus 1, which is equal to 19. So we have variables here X Y Z, which is equal to 0. Now we are going to multiply the coefficient matrix with the variable matrix. So it will become 1 into X plus 1 into Y plus 3 into Z. Then we have 1 into X plus 1 into Y plus 3 into Z. Then 3 into X plus 3 into Y plus 19 into Z. So we have 3x plus 3y plus 19z, which is equal to 0. So here I am framing, separating the three equation by equating to 0. So it is x plus y plus 3z is equal to 0. Then x plus y plus 3z is equal to 0. Then the third equation will be 3x plus 3y plus 19z is equal to 0. So we have the third equations here. Now, after framing this one, see we have a linear equation here. Now we are going to consider any two equation here. The first and second equation is similar. That's why we are going to consider the equation number 2 and 3. So by considering the equation number 2 and 3, now I am going to construct a particular table here by considering the variable x and taking the coefficients of the other variables, that is crossing. Here the equation 2 and 3 is considered. We are considered the variable x I am writing here. Now I am crossing the coefficients of x, writing only the coefficients of y and z here in the form of determinant. So the coefficient of y is equal to 1, coefficient of z is equal to 3, coefficient of y is equal to here it is 3 and coefficient of z is equal to 19. Now I am going to find the determinant value here, that is 1 into 19, which is equal to 19 minus 9, which is equal to 10. Similarly, I am going to find the determinant value for y, but here we are putting a minus sign. So minus y, I am crossing the coefficient of y here, then taking the coefficient of x and z here. So coefficient of x is equal to here 1. So I am writing here 1, z is equal to 3. Here the coefficient of x is equal to 3, then coefficient of z is equal to 19. I am going to find the determinant value. So it is 1 into 19, which is equal to 19 minus 3 into 3, which is equal to 9. Again its determinant value is come out with 10. Now I am going to consider the third variable, that is z. I am going to cross the z variable here and only going to consider the coefficient of x and y. So here the coefficient of x is equal to 1, y is equal to 1, I am writing here. Then coefficient of x here in the third equation, that is 3 and 3 here. I am going to find the determinant value here. 1 into 3, which is equal to 3, minus 1 into 3, which is 3, which is equal to 0. So I am writing here the x by taking the determinant. So it is in terms of, see, I am writing in this particular format, x divided by 10. And here I am minus y taking the determinant value, it is writing here in the denominator, that is 10, plus z divided by, c, here denominator side we are taking 0. Now we are going to divide the both side of the equation by using 10. So it will become 10 divided by 10, which is equal to 1. Here I am taking the minus sign into the denominator. So it is minus 10 divided by 10, which is equal to minus 1. 0 divided by 10 will become 0 and 0 divided by 10 again will become 0. So here corresponding to the lambda, we have a first the eigen vector, that is v1, which is equal to 1, minus 1 and 0. So corresponding to the lambda is equal to 1, we have the eigen vector, that is 1, minus 1 and 0. So now again we are going to find the eigen vector by considering the eigen value is equal to 2. So here the lambda is equal to 2. We are going to substitute in the characteristic equation. So instead of lambda, we are putting it is 2 now. So it will become 2 minus 2, 1, 3, 1, 2 minus 2, 3, 3 and 2, 20 minus 2 multiplied with the variables and equating with the 0. So now if you go for simplifying it, 2 minus 2 which is equal to 0, then what is remaining? 1, 3, 1, 2 minus 2, again it is 0, 3, 3, 3 and 20 minus 2 which is equal to 18 multiplied with the variable matrix which is equating with 0. Now I am going to multiply this coefficient with the variables, so it will become 0x, 1y, 3z, 1x, 0y, 3z, 3x, 3y and 18z equating with 0. I am going to separate this particular terms equating it to 0, then it will become, see, 0x plus y plus 3z is equal to 0. This is equation number 1 I am going to consider. Now here x plus 0 y plus 3z is equal to 0. This is equation number 2. Then 3x plus 3y plus 18z which is equal to equation number 3. So by using these three equations, I am writing here these three equations separately. Now we are going to consider the equation number 2 and 3 here. So equation number 2 and 3 here considering, and we are going to make a table here. So it is considering the variable x. I am going to cross the coefficients of x considering the y and z here. So the coefficient of y I am writing here, it is 0, the z which is equal to 3, y is equal to 3 and z is equal to 18, and going to find the determinant value. So it is 0 into 18 which is equal to 0 minus 3 into 3 which is equal to minus 9. Similarly, I am writing here minus y, here putting the minus sign, y, then crossing the y term here and taking the coefficient of x and z. So it is 1, 3, 3 and 18, and finding the determinant value, 1 into 18 which is equal to 18 minus 3 into 3 which is equal to 9 which is equal to 9. So 18 minus 9 which is 9. Then the third variable, that is z, and crossing the z variable here, taking the only the coefficient of x and y, so it will become 1, 0, 3 and 3. Taking the determinant value of this matrix, then it will become 1 into 3 which is equal to 3 minus 0 into 3 which is equal to 0. So the determinant value is equal to 3. So now I am going to write the determinant value and x, y and z here in this particular format. So taking x divided by taking the determinant value which is minus 9 equal to minus y divided by 9 and z divided by 3. So which is equal to 0. Now if you go for dividing the denominator by 3, then it will become minus 9 divided by 3 which is equal to minus 3. Then here we have 9 divided by 3 which is equal to minus sign I am taking into the denominator, so it will become again minus 3. Then 3 divided by 3 which is equal to 1 which is equating with 0. So here the eigenvector corresponding to the eigenvalue is equal to 2, that is vector 2, that is minus 3 and 1. So here it is minus 3 and 1. This is the eigenvector for the lambda is equal to 2. Now again we have the eigenvalue of lambda is equal to 21. We want to find out the eigenvector for the eigenvalue of 21 also. So it is little bit lengthy. See here, we are going to substitute the lambda is equal to, that is eigenvalue is equal to 21 on the characteristic equation. So it will become 2 minus 21 here. Here we have 2 minus lambda, that is 2 minus 21. Here also we have 20 minus 21. If you go for simplifying it, then it will become 2 minus 21 minus 19. What is remaining? 1, 3, 1. 2 minus 21 which is minus 19. 3, 3, 3 and 20 minus 21 which is equal to minus 1. Variable x, y, z equating with a 0. If you go for multiplying the coefficient matrix and variable, then it will become minus 19x, 1y, 3z. 1 into x minus 19y, 3z. 3x, 3y and 3z here, and equating to 0. And if you go for separating the equation here, equating to 0, then it will become minus 19x plus y plus 3z is equal to 0. This is equation number 1. Similarly, we have an equation number 2, that is x minus 19y plus 3z is equal to 0. And the third equation will become 3x plus 3y minus 1z is equal to 0. Now we are going to consider these three equations, and considering the equation number 1 and 3. Any two equation can be considered, but here we are going to consider the equation number 1 and 3. So here equation number 1 and 3 will be considered, and we are going to write in a separate form, that is x by crossing the coefficient of x term. The y term here the coefficient is 1 and 3, z term is 3, then it is here 3 minus 1. So if you go for find the determinant value, it is 1 into minus 1 which is equal to minus 1 minus 3 into 3 which is equal to 9. So minus 1 minus 9 which is equal to minus 10. Again we are taking the minus y. Minus is putting here before y. Then crossing the y, taking only the coefficient of x and z of the equation number 1 and 2. So it is minus 9, 3, 3 and minus 1. If you go for finding the determinant value here, then it is minus 19 into minus 1 which is equal to 19 minus 3 into 3 which is equal to 9. So 19 minus 9 which is equal to 10. Similarly for the z as well. So z is equal to crossing the z values. Then we have considering x and y coefficient. So minus 19, 1 from the equation number 1 and equation number 3 it is 3 and 3. So I am putting here and we are going to find the determinant value of this submatrix. So it is minus 19 into 3 which is equal to minus 57 minus 1 into 3 which is equal to 3. So minus 57 minus 3 which is equal to minus 60. So now I am going to write this particular terms as like the previous case also. See, it is x divided by minus 10 which is equal to minus y divided by 10. That is I am taking the minus into the denominator. So it will become minus 10 equal to z divided by minus 60 equal to 0. So here we are going to divide in terms of minus 60. Then it will become, see denominator, minus 10 divided by minus 60 which will become 1 by 6. Here minus 10 divided by minus 60 which is equal to again 1 by 6. Then minus 60 divided by minus 60 which is equal to 1 equal to 0. So now these denominator terms are nothing but which is showing the eigenvector of the lambda, that is for corresponding to the lambda is equal to 21. So corresponding to the lambda, that is eigenvector is equal to 21, we have the third eigenvector, that is 1 by 6, 1 by 6 and 1. So in this way we can find the eigenvalues and eigenvector. It is little bit lengthy, but it is all the steps are very easy. I have explained in a simple manner in order to find the eigenvectors. So we have a 3 eigenvectors corresponding to the eigenvalues. We have a 3 eigenvalues, that was 1, 2 and 21. So corresponding to this lambda or eigenvalue, we have a 3 eigenvectors as well. We found the stepwise procedures to find the eigenvalue and eigenvector. I hope it was clear to you, especially about how to find eigenvalue and eigenvector in the case of a 2 by 2 matrix as well as in the case of a 3 by 3 matrix. So of course then we will see in the next lecture. Thank you.